can benefit from it. Number one is, what is motion in a straight line? Well, motion in a straight line does not necessarily mean horizontal straight line motion. It can also be vertical or slanted. It'll be termed straight line motion as long as the object moves in two directions only in a straight line. An object is considered a particle or a point-like object even if it is very large. However, the condition is that all particles in the object should be moving at the same velocity. As an example, even a large truck can be considered a point-like object and its position established on the x-axis. A particle or object's location is given relative to the origin on the x-axis. As a commonly accepted notation, if it is to the left of the origin, it is considered a negative position, and if it is to the right, it is positive. So Minnie here is at a distance of plus 10 meters from the origin if she is here, or negative 8 meters if she is here. A particle's displacement is change in its position and is given as delta x is equal to final position minus the initial position. So if Minnie was here initially and then finally here, then her displacement delta x is equal to x final minus x initial, which is equal to minus 8 meters minus plus 10 meters, which is equal to minus 18 meters. Since the answer is a negative number, the displacement is considered to the left or negative x direction, which indeed is Minnie's displacement. A positive answer would always indicate displacement in the positive x direction. So you see, displacement is a vector quantity. Since in a straight line motion, a particle can move in only two directions, left or right, a plus or a minus sign is good enough to indicate the direction of the vector. It is a positive vector if it moves in the positive direction of x-axis, and a negative vector if it moves in the negative direction of x-axis. So the sign alongside the magnitude indicates a direction of the vector. So the next one up is how to find the average velocity. Well, if a particle has moved from a position xi to x final in a time delta t, then we say that the average velocity of the particle in this time is v average is equal to x final minus x initial upon delta t. So if Minnie moved from plus 10 meters to minus 8 meters in 6 seconds, her average velocity would be v average is equal to minus 18 upon 6, which is equal to minus 3 meters per second. Now the sign you get alongside the magnitude of v average determines the direction of the average velocity. So Minnie has an average velocity that is negative, which indicates the direction of her average velocity is minus x. In any calculation of average velocity, the sign of the average velocity will always be the same as the displacement, since you see the numerator only determines the sign of this quantity, which is the displacement. Now the denominator t is not a vector quantity and is always positive, and therefore has no role to play in determining the direction of the velocity. Also, average velocity is determined only by the final and the initial position and has no relation to the actual distance traveled in time delta t. The next is how to find average speed. Well, it's quite simple. The average speed is the total distance traveled upon the time taken and given as total distance traveled divided by delta t. So speed is not a vector quantity and has no direction but magnitude only, hence a scalar quantity. So the next one is very important, and that is what is instantaneous velocity and how to find it. So instantaneous velocity is velocity of a particle at any instant of time instead of an interval of time. In fact, instant is not even a very short time interval. It is an instant of time like at t equal to 2 seconds or at t equal to 5 seconds and so on and so forth. So we saw that the average velocity is calculated over a measurable period of time, but if you shrink the time being considered to a very small value, in fact, shrink it so much that this delta t moves towards zero value, the velocity you get is the velocity at that point of time. Now you must remember that while delta x and delta t are becoming very small, the ratio itself may not be becoming small. So mathematically we say that limit of delta t is moving towards 0, and in such a case the ratio delta x upon delta t gives the instantaneous velocity at time t, and mathematically it is written as v is equal to limit of delta x upon delta t as delta t tends to 0, or v is the rate at which position x of a particle changes with time at that instant, and we say v is the derivative of x with respect to time t. So the next one is how to find instantaneous velocity on a displacement versus time graph. If you take slope of the curve at any point on an x versus t graph, the slope represents the instantaneous velocity of the particle at that point and is equal to the first derivative of x with respect to t. So an example is if displacement x is related to time as x is equal to 2t square plus 3t, and you are asked to find the velocity at time t equal to 15 seconds, you will first find the dx upon dt, which is a velocity, and equals 4t plus 3 here. Then you will put t is equal to 15 seconds and find v is equal to 63 meters per second. Well, this is also the slope of the curve at this point, or t equal to 15 seconds. If you consider the magnitude of the velocity at any instant, then that is the speed at that point. So the next one up is how to find displacement using time versus velocity graph. Well, if you're given a velocity time graph, then area under the curve between any two times is the displacement of the particle in that time interval. And a positive area always indicates displacement in the plus x direction, and a negative area value indicates displacement of particle in negative x direction. Well, if the graph is a curve, then you can find the displacement between times, say t0 and t1, by finding the area under the curve, and you will need to use integral calculus. So in the language of calculus, the displacement would be x1 minus x0 is equal to integral of v dt as the limits change from t0 to t1. So the next one is, what is average acceleration? Well, if the velocity of a particle changes with time, we say it is accelerating. So if velocity at time t1 is v1 and at time t2 is v2, then acceleration is given as a average is equal to v2 minus v1 upon t2 minus t1, which is equal to delta v upon delta t. So acceleration is a rate of change of velocity, or you could say how much velocity is changing every second. Just like velocity, a positive value of acceleration indicates its direction in the positive x direction, and a negative value indicates its direction as negative x direction. So next is, what is instantaneous acceleration? Now, instantaneous acceleration is the acceleration of particle at a given point of time, or the rate at which the velocity is changing in that instant, and is written as a is equal to dv upon dt. We could also say that acceleration is second derivative of displacement x. So a is equal to dv upon dt, which is equal to d upon dt of dx upon dt, which is equal to d2x upon dt2. Well, how do you find acceleration on a velocity versus time graph? So if you're given a velocity versus time graph, then the slope of the curve at any point on this graph gives the instantaneous acceleration at that point. So you can see that the acceleration is continuously changing in the graph. But for a velocity time graph like this, you can see this is the slope of the graph at any of the point along the line, and therefore this is the constant acceleration during this time interval. You can also see that this slope is positive, and therefore acceleration is in plus x direction. Here you can see that the slope is 0, and therefore the acceleration is 0, and it makes sense also, since you can see that the velocity is constant here, and therefore rate of change of velocity or acceleration is also 0. Now here you can see that the slope is negative, and hence the acceleration is negative and in this direction. Also, this negative acceleration is slowing down the particle, you would have observed that more the slope of the line, higher the value of the acceleration, or more rapid the change in velocity. So, what does sign of acceleration indicate? So, if it's plus or minus, how do you interpret it? So, in normal course of conversation, which we have every day, positive acceleration implies increase in speed and negative acceleration means decrease in speed. However, in physics, the sign of the acceleration indicates a direction of acceleration only and not that speed is increasing or decreasing. So, a negative value of acceleration implies acceleration is acting in the negative direction, and a positive means it is acting in the positive direction. So, if a bike has a velocity of minus 20 meters per second and is brought to a stop in, say, 5 seconds, the acceleration is Vf minus Vi upon time, which is equal to 0 minus 20 meters per second divided by 5, which you see is equal to 4 meters per second square. And you can see the sign of the acceleration turns out to be positive even though the velocity is reducing. It essentially means that the direction of acceleration is in plus x direction or opposing the motion of the particle that is in the minus x direction. In fact, that is the reason that the bike came to a stop. If acceleration was in the other direction, the bike would have actually caught more speed. So, to avoid confusion, use this as a thumb rule. If the sign of velocity and acceleration both are same, that is plus v and plus a or minus v and minus a, then the speed will increase, but if they are opposite, the speed will reduce. I would, however, encourage you to understand more by imagining what is happening to a body or a particle under various conditions of acceleration and velocity rather than just using the thumb rule. And with some thinking and practice, you will start understanding it rather fast. So next up is equations of motion under constant acceleration, and there are three basic equations that define position, velocity and time for motion of a particle if the acceleration is constant. And these are called kinematic equations, and they are v is equal to v naught plus at, x minus x naught is equal to v naught t plus half at square, and the third one is v square is equal to v naught square plus 2a x minus x naught. Now here v naught is the initial velocity, x naught is the initial position, a is the constant acceleration, and after time t, v is the final velocity and x is the final position. When using these equations, remember to use the correct sign. So if at time t equal to 0, the particle is moving at a velocity of 5 meters per second in this direction, you will say v naught is equal to minus 5 meters per second. And if the initial position x naught of the particle at time t equal to 0 is this, then you'd say it is minus 6 meters. And if the final position x of the particle is this, you would say it is minus 14 meters. Then displacement of the particle is delta x is equal to x minus x naught, which is equal to minus 14 minus 6, which is equal to minus 8 meters. So seeing the sign, we say the displacement is in the negative x direction, which indeed is the case. Well, you can memorize these equations once you've understood how they are used. The next one is acceleration under gravity. Now, acceleration under gravity is a case of constant acceleration happening in vertical direction. So instead of taking xx as a reference axis, we take yy as a reference axis. So plus y becomes a positive direction of motion and minus y the negative direction. Now, the same sign notation therefore applies to the direction of velocity and acceleration. We also know that the force of gravity pulls a body in the downward direction, and therefore the gravitational acceleration always acts in the downward direction. The absolute value of g is 9.8 meters per second square, but when we use in any of the equations, we also put a negative sign since it is acting in minus y direction all the time. If you in fact throw a ball up with a velocity of 50 meters per second and are asked to find displacement in 4 seconds, we will use this equation, and that is y minus y naught is equal to v naught t plus half at square, and with correct signs and value it will be y minus 0 is equal to plus 15 into 4 plus half into minus 9.8 meters per second square into 4 to the power 2, which gives y is equal to plus 121 meters. And this turns out to be positive, since indeed the ball is at plus 121 meters after 4 seconds. Well, if the ball is thrown down with a velocity of 20 meters per second from top of a tower and we are asked what velocity is after 3 seconds, the equation will be v is equal to minus 20 meters per second plus minus 9.8 meters per second square into 3, which gives v is equal to minus 49.4 meters per second, and it is negative since the velocity vector is pointing in the minus y direction. So when dealing with objects falling under gravity, the sign of gravity is always negative. So what is the acceleration at the top? Often students think that the acceleration at the top of flight is 0 since the velocity is 0. Well, if this was true, g would be 0 and the ball would just hang in midair. Remember, the force of gravity is acting on the ball even at the top point where it comes to a stop. Hence, g is very much acting on it at the top too, and that is what increases its velocity as it goes down. So the last one is solving problems and making sense of final answer. So most problems we'll solve will be constant acceleration problems where you will be given the value of certain variables. Now the value of other variables may be hidden in the wordings of the problem. Example, a car starts from rest means the initial velocity of v naught is equal to 0, or a ball thrown up reaches its maximum height after 4 seconds means the final velocity is 0 after 4 seconds, and so on and so forth. Be on the lookout for such information in the problem. So you should make neat, well-labeled diagrams and put all information available in it. You will see that when you do so, it will greatly enable you to think the solution to the problem much better. Then identify the correct equation to use based on the information available in the problem statement, and sometimes it may not be as obvious and you may need to write two equations that would have two variables, etc. And finally, when you get the answer to a problem, try to see if answer makes sense. Example, if final velocity is more than the initial velocity, even though the body is supposed to slow down due to acceleration in the opposite direction, you should sense that there is some error in the approach. So make use of these steps, and I think it'll greatly improve your chances of